Okay, hi guys. This is your problem set, and I'm going to do the first problem with you, and this is about derivative graph conclusions. So I'm giving you this graph, and this is of the derivative. So this is the derivative of some function f. We don't know what f is, but we know its derivative graph is this. And we don't know what f is, but given its derivative graph, we can make conclusions about f. So we're going to use the derivative graph to make some conclusions about f. And to make the conclusions, we'll have to look at Susan's table. Okay, this gives, like, all the conclusions you'd need to know are, like, right here, basically. So if f is increasing, f prime is, so f increasing, f prime positive, those are, like, the same, you know, those, this information gives us this information gives us that. Okay, f decreasing, f prime negative, extrema on f, that would be a local max or min, f prime sign change, concave up on f, f prime increasing, f double prime positive. So it's not until we start thinking about, like, concavity of f that we start to include f double prime. And then f concave down, f prime decreasing, f double prime negative. Point of inflection on f corresponds to an extrema on f prime and a sign change on f double prime. Okay, so what we're going to do here, given this graph of f prime, we're going to think about all the conclusions we can make about f and all the conclusions we can make about f double prime. So I'll start with f, and we're going to go if blank, then blank, therefore some conclusion about f prime. And this will give you, if you follow this formula, you'll always have, like, an airtight explanation when you conclude something. So yeah, so I've got the graph of f prime. So I'm going to be starting in this column. So my if part will be, you know, the cause of whatever I'm concluding is going to be found in this column. So let's look for f prime positive. So I look at my graph. Where do I have f prime positive? Well, f prime positive is wherever f prime is above the x-axis. All right, so these sections have positive values, positive y values. So that's where f prime is positive. And if f prime is positive, then what can we conclude about f? That it's increasing. So I'm going to say if f prime greater than 0, then f is increasing. Therefore, f is increasing on what interval? It'll be the intervals where f prime is positive. So from negative infinity to negative 11, union 12 to infinity. On negative infinity, negative 11, union 12 to infinity. If f prime is greater than 0 or positive, then f is increasing. Therefore, f is increasing on these intervals, a union of it. Okay, let's make another conclusion about f given the graph of f prime. So I'm just going to work all the way down. So f prime negative implies that f is decreasing. Okay, so I'll do another if blank, then blank, therefore blank. All right. So this time, the cause of my conclusion about f, the f prime cause about my conclusion about f is going to be that f prime is less than 0. And where is f prime less than 0? All of these sections here. So that's where the graph of f prime is below the x-axis, so it's less than 0. So from negative 11 to 12. Okay, so if f prime is negative, then f is decreasing. Therefore, f is decreasing on this interval from negative 11 to 12. So if f prime is less than 0, then f is decreasing. Therefore, we got that. Okay, so let's see if we can make another conclusion. Yeah. Okay, so we could do a sign change on, so we could look for a sign change on f prime, because that's going to imply an extrema for f. So we'll say if blank, then blank, therefore blank. Okay, so we're going to look for a sign change. So if f prime, I'll say experiences a sign change, then what? Then f has an extrema. Okay, so where does f prime experience a sign change? When it changes here from, at negative 11, it changes, f prime changes from positive to negative, and at 12, f prime changes from negative to positive. So we've got sign changes at negative 11 and 12. Sign changes on f prime, which imply extremas on f. Therefore, f has extrema at x equals negative 11 and x equals 12. Okay, now let's not, I'm changing my mind. We won't do conclusions about f double prime. Okay, we'll just keep going with conclusions on conclusions about f. Okay, so let's do another. If blank, then blank, therefore blank. We're working our way down the line, down the f prime column. Okay, if f prime is increasing, that implies that f is concave up. Okay, so let me say this. Let me say if f prime is increasing, then f is concave up. So where is f prime increasing? So f prime is increasing here and there. Okay, so that's where f prime is increasing. So f prime is increasing on this interval, and it's increasing on this interval. And if f prime is increasing, then f is concave up. Therefore, f is concave up. F is concave up on two intervals. Okay, from negative 8 to negative 6, union from 0 to infinity. On negative 8 to negative 6, union 0 to infinity. Okay, so we just took care of the concave, we just took care of if f is increasing, that we can conclude concave up. Now we'll do f is decreasing. If f prime is decreasing, then f is concave down. Okay, so if blank, then blank, therefore blank. Okay, so this time we're going to have if f prime is decreasing, then f is concave down. All right, so let me look for where f prime is decreasing. Okay, decreasing there. F prime is decreasing there and there. Okay, so I'm going to say therefore f, since f prime is decreasing on this interval, f is concave down on this interval. So I'll say that it's concave down from negative infinity to negative 8, union from negative 6 to 0. F will be concave down there. Therefore, f is concave down on negative infinity to negative 8, union negative 6 to 0. Okay, so I'm going all the way down this column. These are all of the causes that I'm looking for that will result in these conclusions that I can make about f. So finally, we have extrema. Extrema of f prime correspond to points of inflection on f. Okay, so my very last conclusion is going to be this. Okay, so I'll say if f prime has an extrema, then f, then F has a point of inflection. If F has an extrema at a certain value, then F has a point of inflection at that value. That's better language. Maybe I should be saying that. If F prime has an extrema at a value, then F has a point of inflection at that value. That's what we should be saying. That's better. Yeah, like this one here, if F prime experiences a sign change at a certain value, then F has an extrema at that value. That's much better English. Much better communication. Okay, so I'm looking for an extrema on the F prime graph, and that's going to tell me that F has a point of inflection there. Okay, so extremas. So F prime has extremas here, local extremas, and there. Okay, so this means that F must have points of inflection at -8, -6, and 0. Therefore, F has POI's points of inflection, has a point of inflection at x equals -8, x equals -6, and x equals 0. We don't know what F is. We have no information about F, so I can't say exactly what those points are, but I know that they occur at these values. Okay, guys, I'll talk to you soon. Bye-bye.